So hi everybody and welcome back to Unreal Engine 5 full game tutorial series for absolute beginners. This is video 65 and in our last video we stopped there where I tried to implement a count system, a foot count system, so that our monster worm will react to it, and we stopped here at this function where I implemented the first part that was there where we created this counter, and then I said all time when I press the move forward key, which is in my keyboard the W key for example, all time when I press it, then I will count the steps. But the problem was this axis value here, it is giving us many values, and we solved this with a delay. In my case, that was just a random solution. I don't know if this is the best solution. There are probably better ones, but it works. I just say wait 500 milliseconds and then count all inputs till there as one step. Something like that. That was this part here. And here was this two conditions. One is for pressing W. The other one is pressing for S, which means forward is W, S would be backwards, or the arrow key forward, the arrow key backwards, and all time then it should count. So, and here I skipped this one node here, which is a sequence node, and the reason for that is this sequence must do something. And what I want to do is that if I press forward, then of course it should count. That's why I can connect it here, and the count is going up in my case normally, but this one here, the reason for that why it's going up, we need a activation point. And the reason for that is, why do we need an activation point? I mean, here when I press the W key, then it starts to count. The problem is it should not count here at the start. For example, if I start my game, let's see if I'm not interested to counting the numbers here at this point. And anyhow, it's not counting. Let's see why it's not counting. I press this one, I get here. Ah, yes, because I have connected here to the right place. So normally, let's say I have not connected this one. Let's say I have this first one. And if I press now here the play start, you can see, let's see if I'm not interested in counting the steps from here. You can see it. I press forward and then it starts to count the numbers. And after a certain number, I will spawn the screen. So I'm not interested in this. I need the count after the. Oh, that was here down, by the way. Oh, that was here. Yes, here. So I need the count when I reach this collision box, because here the collision box indicates that the monster worm has realized us, and then he will move towards us to our step waves after our count here, right, which we set up. And now I have to find this collision box and implement it here. So how I did this was actually very simple. I said, okay, I make a boolean. Boolean means just a checkbox. And then I created this variable here. And so I click plus, and then I named it worm screen work activation, because here it should start. And then I changed it to a boolean, and boolean means all time a check, and a check is all time in combination most time with a branch. Branch means is more or less say yes or no. So with other words, do you have activate this position? So in our case, are you here overlap with this collision box? Yes or no? If yes, then we will start our counting. If not, you can see the false, do nothing because you are not here. All right, that was this activation box. That was very simple, but careful. That was just the setup. We have to set this activation box, but you can see this one will react. So what I have to do now is find a way to set this. And if you have problems to find, like me, to find where this is, you can all time right click and then find references for example, this one here. You can right click here and then here find references. You can see this one is in this blueprint, and you click this envelope type here, or this binocular type, or what this is. You click on this, and that's is searching all the references in the whole game. And you can see I have already 2 places. The one place was the one which is here, and the other place is the where I set it, and that's very important. That was the thing what I showed you before, and that was my collision box itself. So with other words, here when my character is overlapping exactly this point, and this is this collision box, I need this collision box, and then in this collision box I need to find first, of course, the right right data, because I use here a data table. You can see here here is a sequence, and the data table means I react to the special collision box. In this case is the collision box for the scream sound. I showed you the other collision box. This one is the collision box for the find lighter, and then I will have other collision box. It will create many other. These are this task collision box, right? I set later all the task with it, so I made it easy. I just have to fill in the data table. Later I say here find pistol, for example, make blow out the light and something this, and I instruct this later. But important is you have here find the right collision box, and I did. And then after you find the right one, it can be a little bit confusing. Careful, this data table, because it is using a data table. You can see I check for tag, that was this place, and here the data table. We have talked about this, but again, the data table, when I click double on it, is reacting on this name here, the row input, and this is the tag. Depends on the tag, it will then do something. When I click on this is just the data table which is reacting. But important is this table here, which is here selected, because it reacts to this table here. You get the name, for example, in our case, the scream, and it will react to this table which you have specified here. And I talked about this table in another video, so you should know it. And here you can see the scream sound here is 4. It will react to this one, and you can see the scream sound has, for example, no text, because it is just a scream, but I use a sound. So, and then you can see I can, where is that? I can get this info here. That was the output info, which I can get. At this point, I don't, for example, if this is the scream sound, I have no tag. So with other words, you can see here's out row source wave. This is the sound which will come, but I have also a string. The string will be set to nothing here. So here is just nothing. It will print nothing, but the sound will activate at this point. So when I overlap with my character at this point, this will be activated and the sound will play. There is no text, and then it goes back to the other position. Where is that? Let's go back here. It was that, and then it continues here. And this is the point which I'm interested in, because this is the first scream, and after this one I need activate my counter, and that's why I built in this activation. So what I did here is, because I defined my variable in my character, you can see we have, this is my horror character, and I created here the variable. That's why I need just a reference to this character. And we talked about references. If this is the best case, you have to think on your own. I made this just for fast purposes. I may just create a reference, and how I made this, you can see here on top. We are creating a game mode, and anywhere here we are create a reference too. So you can see here the overlap box, the box here, the collision box here. I mean, it is a collision box, not only here, all the collision boxes are overlapping with my character, and the other object is my character. And then I said just here create a reference. So I made here already the reference. That's good, which means I can just use it here. So here I take the reference and said, okay, cool, get me from my character this this boolean which I defined here, this activation boolean, and here I activate it. You can see I get it here. So here's the character. I show you what I did. I just get the character reference, and character reference means I have now access to these variables here, and I want activated here because I said here this collision box should be activated because my character is at this point. And then I say, okay, it is called here this warm, what is called? It is warm screen walk or something like that, warm. And you can see, and then I have to set this. This is the new thing. It was at start here. It is not set because first I have to set it when I overlap it. And then I connect it after this point. And that's very important here that you find the right point. And that's it. And after you have this step and this step, you have activated it. So that's why it looks a little bit strange here because I made this later. First I programmed this part here, this block here. Then I programmed this activation and then later this one here. All right, that was this activation block. So here you have just to find the right place where you activate it. In my case, it was here. And now it makes, let's go back to this one. We don't need anymore. Let's go back to our code. And here you can see that this one is, let's see, this is just this first part here. Let's make this one. This is the normal code here. The strange thing is here, okay, why I have here the sequence? Because normally I go here and this one will be activated here. I mean, this can be true, okay, this one will be checked all time. That's okay. But this one will be activated here. So the question is now why I need here a sequence. And the point here is the sequence is just here that you still can walk. I mean, the sequence, I have just split up the, let's say, split up the flow a little bit. So I want, actually, I want make something parallel. It's not actually super parallel, but it for our user, it looks like parallel. Even the sequence means first, the first one here, and then after this is finished, then it will execute the second one. But like I said, it is not real parallel, but we as a user think it is parallel because it is so fast we can't differentiate it, which means this move forward, this is just here, when we watch this closer, this is just my movement. So when I move, right, when I press W, I move forward now. That is that. At the same time, I want that it is counting the thing here. And that's why I have added here. Of course, you don't have to use this. Probably you could make this also here behind this one. I think this one is not really necessarily needed. So you could do something like this too. You keep this one here and then just add it from here. Then you could skip this whole sequence. You can see that was just developing my prototype. I made this here. So that was optimization. Yeah, later you can optimize it a little bit better. It was, you can already see this is just prototyping. We can see that I put this code here and here. And yeah, I think that's it for this part here, but there is one more part. And let's think about this. So that was just the activation of the code, of the counter. That was, now I have, let me show you what we have so far. Save this, let's disconnect this part. Let's compile, save this again fast. Let's start it. So what happens now is I have to go here, have the lighter. Let's find the lighter fast. Press the lighter. Normally I don't need the lighter. I could just go there, but let's make the gameplay a little bit more realistic. Let's press here this one. And now I run with the lighter. I skip the pistol here now. Just run, and now I have to find the collision box. And again, you can press here F2, F3 to in gameplay for debug mode, so I can see where's the collision box anywhere. I don't know, see it now, but I know it's anywhere here. So I walk here, and here was the collision box anywhere. Then here is the sound. And because the collision box was here, I already heard it. Here's the sound, and now you on the left side, top, look, there is my counter. And after 10, I will hear the sound again. Let's make it a little bit loud. Oh, we hear nothing actually. And the reason for that is I have just a counter here. Oops. So we have just a counter here, but we have not called the sound again, because now I have to implement the warm reaction. So after, like I said, after 10 steps, the warm will react again, will locate your position and move towards your position. When this is the next step which I have. And how I make this, you can see if the counter every 10, 20 and 30 I make now. This is just for test purposes, not the end data, but this is just what I want to make. And now I show you how I did this one with code. And this is just the last part here, and we hear nothing because I have not connected this one. So here you can see play warm sound in certain interval, and it's very easy. I use the counter which we already created. Let me show you this from start here. So here is this counter which I created. Here is my get it. And then we know we can define a switch. I hope you know what a switch is. The problem here is there is a switch on int, which is normally what you want to use. And in C++, we are using this normally. And the problem here is, I don't know why they implemented it this way, but it is so what it is. The point is, this switch on int, it will take the count of a number. Let's say it is 0 at start, and you can see here is a 0, and then it will activate this one, right? Interesting is you can set the start value. For example, let's say start after 10, then you can see the start value is 10. But the problem on this node is you can't use it to define the other values. In C++, you normally can define this, I think, whatever you want. And that's why I think this is a little bit strange implementation here. Or they missed it, or they just skipped it, because there is another solution. And I want to show you the other solution now, which you can use instead of this. This one is that what you normally would take, because you have an integer here. Then you take the switch, and then you define the numbers when this should be activated. Right, this is the normal way to do it. But in Unreal Engine 5, in this blueprint, you have to take another route. It's also a switch, by the way, but it is another switch. And the switch which you can use is switch on string. Switch on string. In string, we know string is just names, right? So you can, again, you can hear +++ again. This plus means you add your pins, all your out pins which you want. And this time here is a default, by the way. You can remove it, or you can select it and remove it here on the side. It says here has default pin, unclick it, it's gone. And the important part is now all these labels, these names here on the right side in this details panel, you can name it. And now you can write the string as numbers, right? You can just write the number which you want. In my case, 10. After 10 steps for test purposes, 20 steps purposes, 30 step purposes, and so on. What you want. That was anyway too short, I think. I have to change this, but it was just the test purposes in my case. So now you can see I have the numbers, but the problem here, this is string, right? String is not an integer, but nice thing is we can just convert a string to a integer to a string, and you can see you can just plug this in, and this little sign here in the middle is just a converter, which means you can use now the string just like integer. And this is the thing what I showed you normally. Switch on int. Normally you would just directly go to this one here. This is the same thing. And then you change just here the values, and then you connect this. This would be connect directly. You see this one needs no converter, the other one, because this is the right type here. And this one is the workaround, and it works, which you have to use. But that's it. That's all what you need. And then what you need then is just play the sound. In my case, I just write play sound. play sound. And of course, in this case, you can choose at location or something. In my case, of course, not at location, because the worm is not at my location. The worm is far away. And there is a new thing which we have to implement later, which is not here implemented. And the thing is, I have implemented the sound first a little bit not so loud, and every step, every time, and let's say here play sound again, you can see in this second step here, the sound must be more, the volume must be go up right here, and first step the volume must go up. And the question is, why must be the sound louder in the other steps? Because the worm is coming closer and closer. So this is the indication which I have not implemented here. That was just to show you how we implement a sound, and there is the missing part, which is make it louder. Perhaps you can make here just set volume. Is there something like so? Volume. I will figure this out. Perhaps I change here, but here you can see here is a volume multiplier or something like that, and then you can make here, let's see if I promote this to a variable, and then yeah, there is a volume multiplier and something like that, and then you can change here the volumes as well. We will talk about this one in the next video, how we change here the sound with the volumes, so that when the worm comes closer and closer, the sound comes gets higher and higher, louder and louder, right? That's the point. But that's all what I did here. You can see that's the thing. And then I connected this one here, and that's it. So the only thing what I have not implemented, like I said, let's write here a comment here. Comment need to implement sound volumes. Right, this is that what I have to do there. Let's make this color another color just for test purposes. It's just oh, come on. Okay. Ugh, why can't I select this one here? Okay, let's make it this way. Okay, that works too. All right, with that said, we can test this, because that's it for this video. And this is my first system, right? So now let's see, I connect all. Like I said, the sequence not very important. You could connect this one here behind all this one, and then you run this. And here one more thing, of course, there are programmers prefer to put this all in a function. If you like functions so much, you can put this again all in a function. Then you have just a little function here, a little node, which is a function node, and then you can put this function here, and all the code what you see here above will be called, then is placed in a function, and you see here just this little function call, which is also nice for coding purposes if you like this. This is just style and preference and overview. Perhaps it's more, you like more this, but for the work, for the end result, not important. End result is the code, very important that this works. All right, let's test this, see if it's working. Let's see if I find this cultist. I make it very loud now. I walk, you see there is no step counting in the left side, because now I don't want count. It's dark, I have to use the lighter. Let's try to find the lighter fast. Where is it? Ah, here's the lighter. Let's take the lighter. Where is the lighter number? Ah, here's the lighter number. And now I walk. I'm here. So here's the sound. What was that? So here was the sound, and now look the counter on the left side. You see, now I have 3, 4, 5, 6, 7, 8, 9, and now by 10 I play the sound again. Look now. And now I have changed the volume. Like I said, normally you should hear the sound a little bit less. And every next step, so on, let's say on 20, let's say 40, 50, 60, 70. And then on 20, the sound must come closer. And then we have to progress with our storytelling, which means the detective will realize, oh god, what the sound comes closer and closer, and then he realized that the sound is coming closer and closer with every step he's doing. This will be gameplay, and we will talk about this in the other videos in the future. And with that said, I stop here, and like all time, if you have any questions, anything what you want to ask, write it in the comments. And like all time, have fun, don't give up, and yeah, try it on your own. Bye.